Looking ahead to Monday, let's go ahead and take just some notes real quick on some of the highlights that will definitely help you get through the practice printable. We're going to use a combination notes again where we have notes on the left side and examples on the right side. So that way we can kind of organize our notes as we go. The first thing I want to make sure that we understand is the symbols that are being used. The square root symbol kind of reminds me a little bit of the old division symbol that we used back in elementary school. It kind of has this little check mark at the end or over here on the left-hand side, but this is actually the square root symbol. It is known in math vocabulary as a radical symbol. So if you ever see questions where it says to leave your answer in radical form, that would mean you would actually leave it with the square root symbol or that radical symbol. Then we talked about the cube root symbol. And it is the exact same thing, except it's got this cute little 3. So the square root, we know that we're going to have a number times itself that we're trying to find. And a cube root with this little 3 here means that we're going to be finding a number times itself 3 different times. Okay, so that was one thing I wanted to make sure that we understood. The other thing is I just want to review inverse operations. Because when we are solving equations, we're basically doing the inverse or the opposite operation that it's telling us to do in the equation. So just as a quick review, what is the inverse operation of adding? You are correct. It would be subtracting. What is the inverse operation of multiplying? Yes, the opposite operation of multiplying is dividing. And so now with our new information, if we are squaring something to undo this operation, or the inverse operation would be square rooting. So let's switch this up. What is the inverse operation of cube rooting something? It would be cubing. So you can see the relationship there between these new operations that we're adding to our toolbox. Let's just go through several examples here real quick, just so that we can kind of highlight some special instances. First of all, if we have x squared equaling 225, what this means is that there is a number that if I square it, I'm going to get 225. So to be able to find this, I'm going to use my inverse operation. So instead of squaring, I'm now going to square root because our goal is still the same. We want to get x by itself. So I'm going to square root one side, and if I do that to one side, I'm also going to do that to the other side. And since squaring and square rooting undo each other, that leaves me with just x. So the square root of 225 is 15. But there's also another answer. There's another answer that I could put in for x, and after I square it, I would still get 225. Does anybody know what this is? This usually stumps a lot of students. So let me go ahead and tell you. If 15 works, 15 times 15 gives me 225, then a negative 15 will also work, because a negative 15 times a negative 15 is indeed a positive 225. Let's look at another example here. Let's look at x squared equaling a negative 64. Since I'm squaring my variable, I'm going to undo that by square rooting it, and since I square root one side, I must square root the other side. So now I'm going to have just x on this side. And remember what the equation actually means. It means that we are finding a number times itself to get a negative 64. But in this case, there is no solution. Some of you were probably thinking, oh, the answer is 8. Well, 8 doesn't work because 8 times 8 is a positive 64. So 8 is not an answer to this. So then some of you are probably thinking, oh, well, then it's a negative 8. But that doesn't work either because a negative 8 times a negative 8 is still a positive 64. So in summary, if you are trying to take the square root of a negative number, which means you're trying to find a number times itself to get a negative number, it will never work. Now let's go ahead and look at some situations where we would have to do a cube root. X cubed equals 216. So what we're trying to do is we're trying to find the number that if I take it times itself 3 times, I'm going to get 216. So I'm going to do the inverse operation, and I'm going to find the cube root of this, which would leave me with x. And if I find the cube root of one side, I'm going to have to find the cube root of the other side. So x is going to equal 6. Now some of you might be asking, can this also be a negative? Well, let's go ahead and look at it. A negative 6 times a negative 6 times a negative 6. So that would be cubing negative 6. If I take a negative 6 times negative 6, I get 36. And then if I take a positive 36 times a negative 6, I am not going to get a positive because a positive times a negative would actually be a negative 216. So in this case, a negative 6 would not be an answer. Let's go ahead and look at one more example with cubing. If I have x cubed equaling a negative 729, I know that I have to do the inverse operation, so I'm going to cube root on the left side, and I'm also going to find the cube root on the right hand side. Well, this one's easy. It just gives me x by itself. And if I look to see, well, what is the cube root of a negative 729? I know that the cube root of a positive 729 is going to be 9. So in this case, my answer will be negative 9. I can check this out by saying a negative 9 times negative 9 times negative 9. A negative times a negative is a positive, and then when I take a positive times a negative, I will get a negative 729. So these are the highlights from our practice printable from yesterday. And I'm sure you were wishing you would have had these beforehand, but sometimes it's best when we can actually see when they're going to be used and how they're going to be applied. So